So the power rule can be extended and used as the constant multiple rule. And what it says is that if c is a constant, not another variable expression. So we're talking about c as a constant, just like a coefficient. So like instead of just plain x to the third, you had 2x to the third. Okay, you just had a constant coefficient there. You can still use the power rule exactly the same. You simply keep the coefficient c and then multiply the derivative by the derivative of the exponential function. No, not exponential function, the power function, x to the power. In other words, I think this is easier said in words. When you look at it like this, it doesn't make a whole lot of sense. But basically what it says is that if you have something like y equals 2x cubed, even though there's a 2 here, you just keep it. And so if I were going to take the derivative of x cubed, that would be 3x squared, right? So you keep the 2 and you multiply by the 3x squared and you just get 6x squared. So an easier way to say all of this is to say you take the power times the coefficient, subtract 1 from the power. It's just that easy. So if your coefficient isn't 1, you can still use the power rule as long as you remember to multiply the power by the coefficient that is there and then subtract 1 from your power of your x. Now I need you to make sure you understand that you cannot do this if you have variables multiplied or divided. Like you can only do this for a single term of like x to a power. Make sense? Okay. For now, we will extend it until we can find the derivative of basically everything. But the basic power rule only works on monomials of a single variable. If you have multiplication and division of variables at this point, we're going to learn later that you actually have to expand those out. But we will get there. But for now, this only works for just basic monomials, yeah. Now you can string them together through addition and subtraction, and we'll see that in a few minutes as well. Like you can do that across addition and subtraction of different terms. But we're just going to look at some single monomials for now. Got it? Okay. So let's take a look at f of x equals 2 over x. Let's try to find the derivative of that. First thing you have to do is you have to be able to write it as a monomial of x to some power. So I can rewrite that as 2x to the what? Negative 1. Once you get it in that format, coefficient and then x to some power, you can apply the general power rule, which says that f prime of x has to equal the power times the coefficient. So negative 1 times 2 is negative 2. Down 1 on the power is x to the negative 2. Then you simply rewrite that to make your exponents positive. Negative 2 over x squared. And that's your derivative. So in order to use this, you have to be able to envision it as a coefficient times a variable to a power. So let's talk about part B. We have y equals 4t squared over 5. I need to see that as a coefficient times a variable to a power. So most people like to rewrite it like this, 4/5 t squared. Just use the 4 and the 5 as the coefficient, and the t squared can be written out beside it. Then it can be used just like the power rule. Y prime equals what? 2 times 4/5, which is 8/5. Down 1 on the power, which would be t to the first. So we'll pause right there and see if anybody has questions. So for part C, we have h of x equals 2 square roots of x, which we first have to rewrite in exponential form. So 2x to the 1/2 power. Then we can apply the power rule, which states that I can take the power times the coefficient. So 1/2 times 2 is 1, and subtract 1 from the power. So we have 1x to the negative 1/2. Now we can't leave it like that, so we have to drop that into the denominator. So we have 1 over x to the 1/2, which is the same as 1 over what?
X squared.
1 over square root of x. Perfect. Let's try part D. We have y equals 2 over the cube root of x squared. If I'm going to rewrite that, this is really x to the 2/3 power, correct? But if I bring it up to the top, it becomes 2x to the negative 2/3 power. So you have to be really good with radical to exponential form and bringing things from the denominator into the numerator. So some of you will need to kind of work on that. Then we take y prime. That will give us negative 2/3 times positive 2 is negative 4/3. Subtract 1 from the power. Negative 2/3 minus 1 is negative 5/3. And then you simply clean it up from there. You drop the x back into the denominator, and that gives you negative 4 over 3x to the 5/3. And if we rewrite that in radical form, that's negative 4 over 3. Is it the cube root or the fifth root? The cube root of x to the what power? Fifth, right. Remember that it's power over root. A lot of people kind of get those turned around because they get in a hurry. What do you think?
No.
Not too bad? Obviously, radicals are going to cause the most trouble, as you can probably see. Like, those are going to be the ones where you're more likely to make your careless errors. Part E should be the easiest, but for some reason people stumble over it. So let's make sure we kind of talk about it and that you're comfortable. If we have g of x equals negative 3/2 x to the first power, and I try to take the derivative of that, g prime of x is going to equal, what's my power? 1 times negative 3/2 is, and if I subtract 1 from the power, I'm now at x to the
0.
Well, what's anything to the 0 power except 0? 1. So really this just equals negative 3/2. So most people just go ahead and memorize that if you have just an x, the coefficient is the derivative. So like if we have y equals x, what's its derivative? Y prime equals 1, right. If we have y equals 2x, what's its derivative?
2.
And what's the derivative of a constant? We learned that 0. That was the first thing we learned. The derivative of a constant would be 0, and the derivative of a plain x is just its coefficient. We want to look now at these two. They're very similar. The first one is y equals 5 over 2x cubed, whereas the second one is f of x equals 5 over quantity 2x cubed. So we want to look at the difference in how we have to handle these. Right now, you have to get rid of parentheses. Until I tell you otherwise, you are not allowed to differentiate while there is still a parenthesis. So you have to distribute, get rid of your parentheses, and rewrite it as a power. So if I want to rewrite this as a power, what does it become?
6.
The x comes up to the x has to come out of the denominator, you guys. It has to be up in the numerator. You have to bring it up. We need to rewrite it as 5/2 x to the negative 3. Right now the x is in the bottom. If I pull it up to the front or the middle, it will become x to the negative 3. Then you can apply the power rule, and we can say, this is where the calculus starts, right here. Y prime equals negative 15/2 x to the negative 4. Now you can drop the x back to the denominator, now that you've differentiated it. So that equals negative 15 over 2x to the 4th power. Do you have any questions about the first one? Okay. Now the second one has to be, it's going to take a little more to clean it up. Before I can bring anything to the numerator, I have to get rid of the parentheses. So that's really 5 over 8x cubed. Do you guys agree with that? Okay. Then I rewrite it as 5 over 8 times x to the negative 3. And now we apply the power rule. You have to rewrite it as a coefficient and then x to some power so that you can use the power rule. So we have f prime of x is equal to power times coefficient, negative 15/8 x to the negative 4. So that equals negative 15 over 8x to the 4th. So they're very similar answers. The only difference is that instead of just a 2 in the denominator, we had a 2 cubed in the denominator. For part C, we have y equals 7 over 3x to the negative 2. And we can't work on this until we can have it as a coefficient times x to a power. So we need to bring that x to the negative 2 out of the denominator. And when I bring an x to the negative 2 up, it becomes x to the positive 2. So then I can take the derivative. Y prime equals 2 times 7 thirds, which is 14 thirds, x to the 1 power. Power times coefficient, subtract 1 from the power. So that's pretty easy, right?
Yeah.
Okay. When you have a parentheses to a negative power, you can't get rid of the parentheses when it's still attached to a negative power. So you have to move the whole parenthesis and make the whole parenthesis to a positive power. Then you can distribute and get rid of the parentheses. So for y equals 7 over quantity 3x to the negative 2, it's a little bit different. We have to rewrite that as 7 times 3x to the positive 2. And that leaves nothing in the denominator. Then if we distribute all of that out, we get 7 times 9x squared, which gives me what? 63x squared? Okay. And that's just algebra. All we've done so far is algebraically prepare it to be differentiated. So all of that is algebra. You have to get it in a form that you can differentiate from. So we brought the parentheses to the top, we got rid of the parentheses, and we cleaned it all up, and now we see it as a coefficient of 63 times x to the second power. Now you can apply the power rule. Y prime equals 2 times 63 is 126 x to the 1. So they both ended up with x to the first power, but the coefficients were significantly different in this case.